Lenses. A lens is a transparent refracting medium bounded by usually two curved surfaces. The curved surfaces may be spherical, cylindrical, or paraboloid. Okay, let us see the classifications of lens. Usually, we always talk about convex and concave lens. If both the surface are having convex shape, we call it convex lens. If both are concave, we call it as concave lens. What are the other names of convex lens? Convexo-convex, biconvex, bi means two, both sides convex, or double convex. We usually use the term convex lens. As far as concave lens is concerned, bi, both sides concave, concavo-concave, double concave. But we never use these terms, we always use concave lens. Again, plano-convex, one surface plane and other surface is convex. Concavo-convex, one surface is concave and the other surface is convex. Again here, one surface is plane and the other surface is concave. So plano-concave, convexo-concave. These are the broad classifications of lens. Okay. Now we can study some important difference between a convex and a concave lens. The first important difference is the convex lens is thick in the middle and thin at its periphery or edge. Concave lens thin in the middle and thick at its periphery. Convex lens always converges the rays towards the principal axis. It converges. Concave lens diverges the ray away from the principal axis. Convex lens has a real focus. Concave lens has a virtual focus. These are the main difference between a convex and a concave lens. Now, let us learn some important definitions or terms related to lens. First one, optical sender. Optical sender. The geometrical center of the lens is called optical sender. See, suppose, I have taken a convex lens. I have drawn the geometrical center. This O is the optical center. In concave lens, again, the geometrical center is called the optical center. Center of curvature. See, we can learn about center of curvature. See, this is the convex lens. Suppose this is the first surface and this is the second surface. So I am drawing here. This is surface 1 and this is surface 2. So see, this surface is a part of a sphere. Part of a sphere with center of curvature C. Let me say C1. Okay. Again, see, this is optical center. This is pole. So this center is called the center of curvature for this surface of lens. So again, if you draw another for the surface 2, the center of curvature will be somewhere this center of this sphere. So this is called center of curvature. For surface 1 of the lens, the center of curvature is C1, and surface 2, the center of curvature is this C2. The center of spherical surfaces from which the lens is formed are called the center of curvature. See, this lens is formed by this sphere and this surface is formed by this sphere. So the center of this sphere is the center of curvature of this surface, and this center is the center of curvature for the second surface. The next one is principal axis. What is principal axis? The line passing through the two centers of curvature. I already showed you there are two center of curvature for this surface S1 and S2. So C1 and C2. A line is passing through these centers of curvature and extended on both sides. Just I am extending. This line is called the principal axis. This line is called the principal axis. Aperture. What is an aperture? See, aperture means, see, this is a convex lens. This refracting surface where the rays get refracted, this is called the aperture. We can say the effective diameter of the circular outline. The effective diameter of the circular outline of a spherical surface is called aperture. Now, when we are studying ray optics, we talk about thin lens. We talk about thin lens. It is well defined in physics. We cannot simply say thin and thick. There is a definition for thin lens. See, already I taught you what is an aperture. See, if the aperture is less than the radius of curvature, I will teach you what is radius of curvature. Then it is called a thin lens. So if the aperture is smaller than the radius of curvature, we call it as thin lens. Again, one more definition. Suppose if the thickness of the lens is negligible in comparison with radii of curvature. Radius singular, radii plural. That means two radius. A spherical lens, say convex lens, has two radius of curvature. So we call it as radii of curvature. If the thickness is negligible in comparison with the radii of curvature, we again call it as thin lens. Now, it is very important that we should know what do we mean by radius of curvature. Radius of curvature. See, I already showed you this is a lens and this is surface 1 and this is surface 2. And this lens is a part of a sphere. Surface 1 center of curvature is C1 and for surface 2 center of curvature is C2. See, we always talk about thin lens. Actually, somewhere geometrical center here there will be optical sender. But if the lens is very thick, we measure the distance from the pole. So for this surface, the center of this refracting surface is pole P1. P1 I am writing so that it is the center of the refracting surface S1. Again, P2 is the pole of the refracting surface, second refracting surface S2. Now, what is radius of curvature? We know C1, we know C2. So P1, C1. P1, C1 is radius of curvature. And again, P2, C2 is also a radius of curvature. So we talk about radii of curvature. Radii. Radii means plural. Radius 1, radii plural. Radii of curvature. Because P1 curvature, C1 P1 and C2 P2. So we can write R1 is equal to P1 C1. R2 is equal to P2 C2. They are radii of curvature. The next one is pole. See, I already taught you pole is the center of the refracting surface. So this is surface 1, this surface is pole and this is also pole. So I say P1, P2, center of the refracting surface. Optical center is the geometrical center. So the point, so this point, the central point of the refracting surface, at which the principal axis meet. So the principal axis meet at this point. So the point at which the principal axis meets the surface of the lens is called pole. Next one is focus. What is focus? Focus is the point. Focus is a point at which the principal axis, see, this is the principal axis of the lens, it goes undeviated straight. Okay, the principal axis. So focus is a point on the principal axis at which the rays parallel to the principal axis. See, if it is a convex lens, it actually meets. If it is a convex lens, they actually meet. If it is a concave lens, they appear to meet. They appear to meet. They will not meet, they appear to meet. So you can write the definition as, for convex lens, focus is the point. It is the point at which the principal axis, the rays parallel to the principal axis meet. It is the point where the rays parallel to the principal axis after refraction meet. This is called focus. The next one is focal length. I told you we always calculate the distance from optical sender. If the lens is very thin, we calculate from pole also. So the distance from the optical sender to the focus is again a point. The distance from the optical sender to the focus is called focal length. The last one is focal plane. Focal plane. You all know what is a plane. Okay. The plane passing through the focus and perpendicular to the principal axis. This principal axis passing through the focus and perpendicular to the principal axis is called focal plane. So I have given almost 10 important terms related to lenses. You should have a proper understanding for doing derivations and solve various numerical problems.